through these two. What do you remember that we need to do first when we're asked to find the equation of a line passing through 2 points? Yes, Brian?
Determine slope.
Yes, very good. So this is x1, y1, and this is x2, y2. So I will start with the slope, which is y2 minus y1 over x2 minus x1. It's not a monologue. Don't feel reluctant to ask questions. You can stop me anytime. All I have to do is replace 5 minus 4 over 2 plus 3. Any questions anytime, please? The numerator is 1. The denominator is 5. Agreed so far? Very good. So now we have two equations. This is something I would write in my notebook to refresh or remember the definition of the slope. We have two equations of the line. Y equals mx plus b, which is slope-intercept form. I like to call it slope Y-intercept form, where this is the slope, and this is the Y-intercept, 0, comma b. Y-intercept, 0, comma b. The other form is, anyone remembers what is the other form of the equation of the line? Please.
Is it y1?
Exactly. Y minus y1 equals the slope.
X minus x1.
Excellent. So this is what is called point slope form. And this is what we need in this case. It doesn't matter which point I use. Let's suppose I use this one. So then y minus y1 equals the slope times x minus x1, where x1 is negative 3, the slope is 1/5, and y1 is 4. At any point in time, feel free to use your own method. I like to write it underneath before I write it again, because I may copy something wrongly. So I write it like this first. And then I write it again. Y minus 4 equals 1/5 x plus 3. Why plus 3? Because it's minus minus, bless you. Normally we have to solve for y at any point in time, so I will distribute 1/5 x plus 3/5, and then I have to add 4. As we discussed last time also, you can write this down on your memory notebook. When I move a term from one side to the other, all I have to do is change its sign. Now the question is, how do I add fractions? I have to find the least common denominator, which is, since there is only one denominator, obviously it's 5. And I have to change this into 20 over 5, right? So it's 23 divided by 5. So this is the equation of the line passing through the given points. Nothing so far. Any questions? If you need paper to write on, I can give you some, or if you need anything, let me know. I have to find the least common denominator. So 3 over 5 plus 20 over 5 is 23 over 5. Better? So now, let's look at the following scenario. You need help, Griffin? Can you help him with the... Oh, are you okay? Yeah. Okay. Good. So here's a following scenario. This is a function f of x. This is a point P. And I'm going to say that the x-coordinate of P is x. Can anyone give us the y-coordinate of P? What do you think? Correct. there is another way of writing y. Perfect. Is there another way? Of course it's y. But there is another way. Remember, the point is on the function. If its x coordinate is x, what will be the y coordinate? If this is 5, how do I find this? Correct. So if this is x, this must be? Of course. Perfect. Any point on the graph of a function must have x whatever and the y coordinate through the function, f of x. Otherwise, it will not be on the function. Is that clear? Yes? If I'm given a function, f of x, let's say is x squared, and I ask you to determine the point whose coordinate is 10, and it's a point on the function, what will you say? How much is y? Right. You have to plug it in. This must be f of 10, correct? Right? So this must be 100, which is nothing else but f of 10. Coming back to our point, if the x coordinate is x, the y coordinate must be f of x. Okay, so I'm going to create another point, which is q. Q has the x coordinate x plus a little bit. And you can say this does not look like a little bit at all. Well, I'm zooming in. So h is a little bit. Tiny. Okay, can anyone give us the y coordinate other than Brian?
X plus H.
Say it again.
F of X plus H.
Awesome. F of x plus h. Very good. Perfect. Okay. It makes sense, correct? Okay, very good. So now I would like to determine the slope of this line. I want to find the slope of the line PQ. And we just refreshed our memory on the slope of a line passing through the 2 points. Yes, I'm ready. You want to try? No. Okay, anyone?
It would be f of x plus h minus f of x
Awesome.
over x plus h minus x.
Good. In the previous class, I'm sure you've been tortured enough with this. But this is 80% of this course. So we're going to name it in a minute. I'm sure you remember its name, but never mind. For now, these two go away. So this is f of x plus h minus f of x divided by h. Anyone remembers the name of this? Awesome. This is indeed a difference quotient. Now I'm interested in the meaning of this. And why am I doing it? In a moment you'll see. For this function in problem 7, and then we'll go back to 5. Okay. What does it mean? So what is the meaning of the difference quotient? It looks very interesting. F of x plus h minus f of x. So first of all, what is h? It's a tiny error. Let's suppose I'm manufacturing discs or pencils, whatever. And my pencils or my discs are not all this. They're not all of them have the same diameter or circumference or radius, whatever you want. They have a tiny error. So if there is a tiny error in the diameter or in the radius, obviously, if I'm looking at the area of the disc, that will trigger an error in the area, right? So if I want the radius to be 5, but it's 5.01, obviously the area is not going to be 5 squared times 5. It's going to trigger an error in the area. So this is a minor error in the x value, whatever the x is, radius, circumference, diameter, that will always trigger an error in whatever function I'm looking at. If it's the area, if it's the volume of the disk, whatever it is. So a minor error in H triggers a minor or whatever error in the function. So what will this be then?
About.
Yes, what will this mean? The rate of change, it's the rate of change of the function f of x between p and q. So let's write this down. The difference quotient is the rate of change of f of x between p and q. Sorry. Okay, the rate of change of f of x between p and q. Perfect. Now, here is the next concept that I need for chapter 1. I'm not jumping over R. I'm going to do R, but I need it right now. We're going to see it many times. So let's say I do this now. I take point Q and bring it closer and closer and closer to point P. Not overlapping, because that, I'm telling you then that Q and P are the same. No, they're not the same. So what if I bring Q closer and closer, closer and closer to P? What would happen to H? Smaller and smaller, closer and closer to 0, not 0, because I'm not making Q to be P. I'm not going to do that. I can't do that. But then what will happen to this line that is now a secant line, nothing with trigonometry, nothing to do with trigonometry, but it's a line that cuts a function in 2 points. That's secant line. So what will this function do? If Q is here, then if Q is here, and then if Q is here, so as Q gets closer and closer to P, the secant line becomes, or gets closer and closer to becoming, what?
0.
The tangent, right? So if this point gets here, this is how the secant line will look. If it gets even closer, this is how the secant line will look. It will become what? The tangent. Tangent to a point touches the graph of the function only in that point. So let's write this down. As Q approaches P, so this means approaches. As Q approaches P, H approaches how much?
0.
Very good. The secant line PQ will become what did we just say? Very good. Tangent at P. And now what I'm interested in is the slope of the secant line PQ will become, or get closer and closer, I should say. The slope of the secant line PQ will become closer and closer to the slope of the tangent at P. So when Q moves closer and closer to P, H gets closer and closer to 0. The secant line gets closer and closer to becoming the tangent. And the slope of the secant line obviously will be closer and closer to the slope of the tangent line at P. These all happen because I'm moving Q closer and closer to P by making H closer and closer to 0. Okay, so what I would like to do now is pick this function or another function and find the difference quotient. Two things happen every time we determine the difference, or determine and simplify the difference quotient. Two things. I'm going to write this down. So every time we determine and simplify the difference quotient, the first thing that happens, number 1, all terms without H at the top will go away. And the second thing that would happen, this h in the denominator must go away as well. I'm going to write it together with you. For any function, and we will choose a couple. For any function, the difference quotient, dq, how do you want me to write it? It has two faces, two steps, has two steps. In step 1, all terms without little h, that minor error, must go away from the numerator, sorry. In step 2, for any function, in step 2, h from the denominator also must go away. Meaning you will simplify. We're not going to erase it. Okay. So looking at this, what do you notice? We're asked to perform the calculations and fully simplify this expression. Can you tell me what this is? Let's copy it. 1 divided by x plus h squared minus 1 over x squared, everything divided by h. Does it resemble anything? And if it does, for what function? What function is this?
Is that a circle?
No. So, what is this? It's 1 over x squared, right? What is this? It's 1 over x squared with x plus h instead of x. So if you go back to what we just wrote, f of x plus h minus f of x divided by h. So then one more time, for which function is this?
Difference quotient.
Yeah, it is a difference quotient, but for which function?
1 over x squared.
That's it. It is a difference quotient for 1 over x squared. In this class, we have to remember the definition of the difference quotient. So please get used to it. So the difference quotient is f of x plus h minus f of x divided by h. Now, one more time, do we know what this is and where it's coming from? It's the rate of change of this function. If you want for a minor change in h, there is a it triggers the minor change in x, triggers a change in y, and this will give us this, the slope of this line will give us the rate of change between p and q. The rise over the run. The slope of this line. Now, by the way, every rate of change has a measurement unit that comes from, it's a ratio of the rate of the measurement unit of the top over the measurement unit of the bottom. So if you call me and I'm driving and you ask me what is your speed right now, I will look at the speedometer and I'll say 60. No, I will say 60 miles. No, I will say 60 miles per hour, because I have the rate of change of distance with respect to time. The measurement unit for the top is miles. The measurement unit for the bottom is hours. So every ratio, like this one, difference quotient, will always have a measurement unit coming from the top over the measurement unit coming from the bottom. So please keep that in mind. So we're asked to simplify this difference quotient. we already have the function, right? It's 1 over x squared, which is 1 over x plus h squared minus 1 over x squared divided by h. Okay. What do we have to find first? The denominator can be written as h over 1. So what do I have to find first? And here's the hint. The least common denominator. Very good. What is the least common denominator? There are two different factors. One factor is x. The other factor is x plus h. All different factors have to be in the LCD. So then this is x squared times x plus h squared. I have to use those powers because that's what they have. So now x plus h squared was multiplied by x squared, which means I have to multiply the numerator by the same thing. Very good. X squared was multiplied by x plus h squared. I need to multiply the numerator by. Very good. Awesome. So now can anyone dictate the numerator of this fraction? Yes? Minus x plus h squared. Remember, two things have to happen. All terms from the top of this fraction, after we flip it in a minute. So all terms that do not have h at the top must go away. And eventually this h must go away. So now I have a fraction divided by another fraction. How do I perform a division of two fractions? What do I need to do? I copy the numerator. And what happens to the denominator? Yes. Very good. 1 divided by h. And now let's decide what to do with the numerator. I'm going to copy x squared minus, but now I have to remember from last time when we refreshed our memory on this special product, binomial squared, I have to remember what to write and how many terms. How many terms do I have to write? 3 terms, right? So, and then I will have to distribute negative sign to all 3 terms. Can anyone give us those 3 terms from the special products from last time?
X squared.
Very good.
2xh.
Yes, but
minus 2x.
very good.
And then h squared.
Very good. Awesome. X squared, it should have been x squared plus 2xh plus h squared, but we distribute negative 1. Distribute it to all 3 terms. Are you with me, everyone? Yes? Any questions? Please ask. Is this okay? So the terms without h are going away, and they should. Then I look at the 2 terms at the top and I see they have a common factor. What is the common factor? Yes, I will factor out however negative. It doesn't matter, really, that much. What is left in parentheses? And how many terms?
2x.
Yes? Awesome.
Minus h.
Very good. Do we all agree with 2x plus h? So what is the second step that has to happen then? The first step was when all terms without h go away. Exactly. We've done this in the previous class. No one said that the final simplified form of the difference quotient for this function may not have an h left in there, and it does. Of course, other terms that have h may go away, and that's a bonus in step 1. It's possible in certain situations then more than just the terms without h go away. It's a bonus. I'm happy if that happens. But all terms without h must go away. Then we factor out h that will go away with this h. And that's the second step. So this is the simplified form of the difference quotient for this function. It gives the rate of change of the function at any point x under certain conditions. Any questions? Yes, please, right?
Writing it like that is the same as writing it as negative 2x minus h, right?
Correct. Yes. We like to pull out the negative leading coefficient at all costs, if we can. Yes. Okay, so the last review that I would like to look at, this is what we cover in chapter 2, and you'll see why and what it is. So the last thing that I would like to review with you is graphing a piecewise defined function. Let's see if we can use a different one. Since I'm here and we're here and we're going to have to go over the review anyway. Let's choose, if you have your book or your ebook, I will ask you to choose a problem from your book. They are on page, not on this one. So are we all in my math lab? Are we signed up? Everything? Did everything go okay? Brian, did everything go okay with you?
Yeah.
Is there something wrong? Yeah, I see that.
Often the thing, it like stops and then it goes 5 seconds really fast.
Oh.
He wants to catch up.
Probably for a second.
That's so funny. That is funny.
Yeah, and I don't know if anybody's listening to my math lab code, but it's on eBay for $60.
Oh, it's somebody's code?
No, it's the same gentleman I purchased from last semester. I don't know where he got them from, I don't ask, but it's $60 for a code. Yeah.
And opportunity free trial.
Yeah, that's right. We do 14 days. You just go ahead and do all that homework for the entire semester.
Yeah, that's a good idea.
I can't find one at this moment in time. I just want to quickly find one. And I think they are already, I'm pretty sure now. Yeah, they're already in chapter 1, but that's fine. I need them anyway. So if you'd like to choose, you can from page 104. Anyone has a book we would like to choose? So anything you like from 62 through 68 on page 104. It's now or never is the same thing. So
It's taking a while to load.
that's okay. I'm going to choose 68 then. And 68 is a function g of x, 2 plus x, for x less than or equal to -1, x squared, for x between -1 and 3, sorry, and 9 for x greater than or equal to 3. So it's now or later, I meant to say. It's the same thing. I need this anyway. Okay, so the question here, or the requirement here, is to graph this function. Okay, it looks awful, right? Initially, when you look at it, you say, oh no, right? The name of this function is piecewise. Why is it piecewise?
It's 3 pieces.
It's 3 pieces, exactly. Which means these 3 pieces cannot overlap. In other words, for the x values between -∞ and -1, the function is this. And it cannot change and it cannot be extended. Between -∞ and -1, I have one function. I'm done. I move on to the next piece. Between -1 and 3, there is a different function, and I'm done. I'm moving on to the next piece. Between 3 and infinity, it's a totally different function. I'm done. And these three functions cannot overlap, because if the function, the two or three functions overlap, this is no longer a function by the vertical line test. So this is like, imagine, Brian can tell us and can teach us about taxes. I don't know anything about the tax code myself, to tell you the truth. But in the past, I don't know what it is right now, but in the past, for a certain amount of income, people would pay 10%. For the next level, 15%. For the next level, 20%. This is a piecewise defined function. They cannot overlap. Somebody who has the income between this and this cannot pay 15% and also 20% and also 30%. So this is a piecewise defined function. Okay? So we are asked to graph it. There are many steps to it. Graph it. Why do we need to know how to graph such a function? It is because of the concepts that we are going to learn in chapter 1. Every time I'm asked to graph a function, my first thought always, ever is what? Always. What do I have to find first? Before I think of anything, shape or anything else.
Slope?
No, that's only for the linear function. Yes, but not before. Correct, but not before I find what? Domain, very good. The domain is the starting point every time I graph a function. So this concept is again for your notebook. Every time I'm asked to graph a function, I have to find the domain first. Okay. With your permission, I'm going to change this into -∞, -1 with a bracket and a parenthesis. If you don't remember this concept of the interval notation, please tell me and I will explain it. Is this okay? Do we understand this?
Yeah.
Less than or equal to -1 from -∞ with a parenthesis. Because of the equal symbol, I have to put a bracket. Can anyone give us the second interval? How will you write this one from -1 to 3? Please.
It's your parentheses, -1, comma 3 parentheses.
Awesome. And how do we write the last one?
Bracket 3, comma 3.
Very good. Now I'm sure you're asking yourselves, okay, isn't that good enough? Why do you change this into interval notation? You'll see in a moment why I'm changing it into interval notation. Now I get a chart going. Can anyone give us the domain? This is g of x. Can anyone give us the domain by looking at -∞ to -1, including -1, -1 to 3, including 3, and to infinity? Can anyone say the domain is, because we are talking about the entire function, that is made up of 3 pieces. The entire function's domain is?
R.1.
Perfect, excellent. Thank you, Griffin. Excellent. It is all the numbers. Very good. Let me see if I tilt this. Is it better? Okay. These key numbers, -1 and 3, must be in the table. 0 must be in the table always. But in this case, these are the 2 key numbers, -1 and 3. Here's what I'm going to do next. And it comes from the interval notation. Under -1, to the left, I see a bracket. To the right, I see a parenthesis. Right immediately under -1, I would put a bracket to the left, touching a parenthesis to the right. This is the bracket, and this is the parenthesis. The bracket is from here, facing that way, and the parentheses from here, facing the other way. Can anyone give us the symbols, same symbols under 3. What?
See in the graphic.
Yes. Again, if you're asking yourselves why I'm doing this, just wait for 1 more minute and you'll have the answer. I'm going to ask something that is an overkill now. Can you please tell me which function we have to use for x values between negative infinity and negative 1? And there is only one function. Which one? And you can say you have it right here in front of you. True. I want it right there on top of the table, though.
2 plus x.
Do you all see 2 plus x? Yes? Okay, between negative 1 and 3, which function will I use? As I mentioned, it's an overkill. Yes, very good. And for the last one? 9, indeed. Why do I want to do this? It's because the branches up here may not be given in the correct order. So by re-emphasizing which function goes with each x values, I'm minimizing my chances or risks of errors. Okay. So now, what type of function is this? What type of function is this?
Linear.
Linear. Very good. How many points we need for a linear function, to graph a linear function?
2.
Very good. What type of function is this? Quadratic or parabola if you want, yes. So I have enough, 3 points. What about this? Linear. I need 2 points. Good. So now, to the left of negative 1, of course I'm going to use negative 2. Why? Because when I plug in negative 2, what do I get? Perfect. Please plug in negative 1 and write inside the bracket a number. Which number? Perfect. Now please plug in negative 1 in x squared. And you should say, time out, time out, time out. You can't do that. You cannot plug in negative 1 in this function because negative 1 is not here. Negative 1 is only here, not here. But if I don't plug in negative 1 and leave it as an open point, then I would have to plug in negative 0.99999999999, the immediate number to the right-hand side of negative 1. I don't even know what it is, to tell you the truth. So I will plug in negative 1 and leave it as an open point if these two numbers are different. If these two numbers are the same, there's not going to be an open point there. So when I plug in negative 1, what do I get? 1. So it happens that there is no jump here. This ends at 1 and this starts at 1. Okay, let's also plug in 0. What do I get? Good. Let's now plug in 3. 9. Plug in 3. 9. Plug in 4. 9. A very simple situation, actually, because these numbers are the same. So let's graph. From left to right, please give me the first ordered pair that I need to plot. Very good. The next ordered pair with a full point. This is a line. I'm done with that piece. Next piece. Negative 1, 1, 0, 0, and 3, 9. I'm going to say that this is 9. I'm going to say 3, 3, and 3. This is my 9. I can't because I already have this one. I'm going to start again. Sorry. I didn't plan ahead. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So you already gave me negative 2, 0. And then negative 1, 1. So here's the graph. Then you said it starts at the same point. And then you said 0, 0. And then you said 3, 9. Should be an open point. This is a parabola opening up. However, 3, 9 starts at the same point and continues horizontally with y equals 9. So this is the graph, and it happened that the left and the right were the same point for both. Can anyone give us the range of this function? Yes, please. Awesome. Very good. Yes, please.
I just had a quick question.
Please.
On the graph, all the circles appear to be closed.
Yes.
Are they all closed?
Yes, they are all closed because, and I'll give you another example now. They are all closed because these numbers are the same.
Okay.
If this, for example, were 3 or any other number than 1, there would have been a gap, a jump. So in other words, this would have, I'm not going to correct this, but this would have ended here, and I would have had a totally different situation. I'm going to show an example right now. So that's how we handle a piecewise defined function. Okay, let's also look at 67, because I want to show the possibility, still the same page, 104. One more example. So this time we are looking at h of x. Before we continue, can anyone make other comments, or if you have any questions about this? Is this clear? Does it make sense? Is this okay? I can give you paper if you want. You want some? Are you okay? Okay. So any questions on how to graph the piecewise defined function? Okay. Very good. So here's another one. X plus 1, 2, or 3 minus x. And the first one is for x less than 0. 0 between 0 and 1, and greater than or equal to 1. Okay. We want to graph this function. First, I need to find a domain. Not all functions are defined on all real numbers. It may happen, but it may not. How will I write x less than 0? In interval notation.
0 to infinity.
Negative infinity, right? To 0 with parenthesis. Good. The middle branch.
Bracket 0, comma 1, parentheses.
Awesome. And the last one. 1 to infinity. Now, can anyone give us the domain of the entire function? The first piece is defined on something, the middle piece on something else, the last piece on something else.
Negative infinity to positive.
Do you all agree with that? That nothing is missing, no gaps in the domain. Indeed, all real numbers. Which x values are key, and they have to be in the table? Key points or key x values.
0.
And? Perfect. What symbols do I write under 0?
Parentheses, bracket.
Parenthesis to the left and bracket to the right. Awesome. And under 1?
Parentheses, bracket.
The same thing. Very good. Which function will I use for the first interval? I know it's an overkill. I know it's right there, but it may not be arranged correctly. Which function?
X plus 1.
Perfect. In the middle.
2.
And the last.
3 minus x.
Very good. It appears that all these three functions are what type? Perfect. Let's plug in 0. Let's start with -1 actually. Plug in -1 and we get, very good. Plug in 0, very good. Plug in 0, plug in 1, plug in 1, and plug in 3.
0.
Perfect. From left to right, please dictate the first ordered pair.
-1, 0.
Very good. The second ordered pair.
0, 1.
What type of ordered pair will this be?
An open circle.
It will be an open circle. And here's the line. We're done with the first branch. We cannot extend it to the right. We can't touch this. That's it. The next step, next ordered pair is?
0, 2.
Very good. What type of ordered pair is this?
Closed circle.
Very good. 1, 2. This is the middle piece, which is 2. However, the next point is 1, 2, so I have to fill this in. And then 3, 0. So I have to go back and fill it in. Notice one more time that these functions do not overlap. This is only between -∞ and 0. This is only between 0 and 1. And this is only between 1 and infinity. Can anyone give us the range of the entire function? From the lowest y value?
-∞
Very good. Till the largest y value, -∞ to 2. Okay. Since we're here, I'm going back to R in a minute, but since we're here, I want to ask you just a quick question. Looking at this graph, if I ask you if x gets closer and closer to 0, so x coming from -∞ closer and closer to 0, closer and closer to 0, from the left, the function values get closer and closer to which value?
0.
We see that?
Yes.
So as x approaches 0 from the left, the function values get closer and closer to 1. Agreed? Okay. Now let's look at the other side. If I'm coming now with x from this side, as x gets closer and closer to 0 from the right, the function values get closer and closer to 2. Very good. Final question. As x gets closer and closer to 1 from this side, the function values get closer and closer to
1, 2.
2. We see that? We see 2? Yes? Yes?
Yes.
Okay, so now when x gets closer and closer to 1 from this side, maybe I should do this, the function values get closer and closer to which value? 2. Do we all see that? This is the concept of the limit. So now, final question before I go back to R. We're not there yet. Because the left-hand side, when x approaches 1 from the left, and when x approaches 1 from the right, because both sides approach which number? 2, we will say that the limit exists from either side. Should I show it again? Very good. As x gets closer and closer to 1 from this side, the function values will get closer and closer to 2. That's the 2 level. As x gets closer and closer to 1 from this side, again, the function values get closer and closer to 2. So from either side, the limit will be 2. What about here at 0? As x gets closer and closer to 0 from the left, the function values approach, right? We see that? At the same time as x gets closer and closer to 0, y values get closer and closer to 1, right? On the other side of 0, as x gets closer and closer to 0 from this side, then the function values get closer and closer to 2. Is there a limit from either side? Here from either side, the limit was 2. But here from either side, the limit, I don't know what to say. On the left is 1, on the right is 2. So from either side, the limit does not exist. It exists from the left, which is 1. It exists from the right, which is 2. But since they are not the same, the third limit from either side does not exist. The limit from this side is 1. The limit from this side is 2. Yes, this one exists from the left, is 1. This one exists. Yes, is from the right, is 2. But when I say the third, when I talk about the third limit from either side, it does not exist. It has to be a unique number, and it's not. This one is at 1, this one is at 2. Okay. Yes, please.
So
Yes.
you were saying there were 3 different limits.
Limits, correct.
Is that because it's 3 pieces to this piecewise, or it's just always 3?
No, there is always 3 for everything, for every point. So for example here, the limit from the left is 0. The limit from the right is 0. The limit from either side is 0. Is that clear? We're going to get to limits. I had this graph up here, and I had to just give you the heads up. Okay, so I would like to, I know we have about 20 minutes left.